Artificial intelligence will help save bees. The world's first network of intelligent hives powered by artificial intelligence has been launched in the UK. The project aims to help combat the declining bee population. It's estimated that 100 crop species provide 90% of the world's food. 71% of these thrive thanks to bee pollination. Unfortunately, their populations are steadily declining. Over the past 25 years, the population of honeybees and other beneficial insects has declined by 75% in some European Union countries. In England alone, the number of honeybees declined by 54% between 1985 and 2005. This is due to factors including pesticide use, climate change, and diseases affecting insects. According to a 2016 report by the Intergovernmental Platform on Biodiversity and Ecosystem Services, IPS, other pollinator populations are also declining. Bumblebee populations are declining in northwestern Europe, and bat and hummingbird populations are declining in North America. Long-term monitoring at the national and international levels is needed to provide information on the status and trends of pollinator populations in most regions of the world, the report states. In the long term, failure to take action could lead to the extinction of some plant species, resulting in food shortages and a decline in agricultural employment. This global problem has prompted scientists to utilize cutting-edge technology in the fight to preserve bee populations. In 2014, Sabaya Malik invited University of Reading biologist Simon Potts, co-author of the IPS report, to co-found the World Bee Project. Scientists from around the world and technology partners joined the project. In collaboration with Oracle, work began on a project to create a network of intelligent hives, called the World Bee Project Hive Network. These hives will utilize cutting-edge technology to help maintain bee populations. The World Bee Project Hive Network will remotely collect data and then feed it into Oracle Cloud, which will leverage analytical tools, artificial intelligence, and data visualization to provide researchers with insights into the relationships between honeybees and their environments. This system will allow researchers to listen to bees analyzing complex acoustic data recorded in smart hives, including bee wing movements. Combined with other precise measurements such as temperature, humidity, and honey production, this information will allow researchers to closely monitor bee colonies, detect patterns, and predict behavior. This will allow beekeepers and conservationists to take appropriate action to protect entire colonies, such as preventing swarming at inappropriate times of year or combating predators. Nature conservation today cannot exist without technology. The World Bee Project Hive Network is a unique example of how one of the oldest, traditional industries can leverage cutting-edge cloud technologies, noted Piotr Witczynski, acting CEO of Oracle Poland and head of Oracle Consulting in CEE and CIS. Data and information generated through Oracle Cloud will be shared with research and conservation projects working to protect bees worldwide. This will provide researchers with the information they need to collaborate with governments, and provide beekeepers with information they need to help curb bee population decline. A fascinating element of this project was the opportunity to conduct research with ordinary people using image, voice, and video recognition, said Ian Sharp, a specialist in Oracle's cloud innovation team. To obtain the most accurate results from image and video processing, analysts are increasingly building open-source deep learning libraries, but implementing them is a significant challenge. At Oracle, we've created an innovative solution that addresses these needs, enabling the easy and reliable deployment of mixed models from libraries like Keras, CAF2, and TensorFlow with optimized performance. Analyses based on data collected from around the world will help answer the question of how to improve the situation for honeybees. In turn, weather data, mapping data, and freely available government data will supplement scientists' and beekeepers' knowledge of hive health. As the amount of data increases, machine learning technologies will begin to detect patterns in the data, leading to the development of new research methods. Establishing a partnership with Oracle is a breakthrough for us, said Sabaya Malik. Using an autonomous database that recognizes patterns is a realization of science fiction scenarios in a positive sense of the word. We have the potential to help transform food production worldwide and protect the livelihoods of hundreds of millions of farmers, noted the project's initiator. Extrasolar Planet discovered orbiting 3 stars. In recent decades, astronomers have discovered thousands of extrasolar planets. Some orbit a single star, like Earth around the Sun. Some formed in binary systems, but now astronomers report the discovery of an exoplanet orbiting a triple star system. This very rare type of Jupiter-sized planet is located in the constellation Orion and orbits 3 stars simultaneously. Traces of an exoplanet were discovered in the triple star system GW Orionis, located about 1,300 light-years away in the constellation Orion. This system consists of 2 stars that orbit each other every 241 days, and a third star that orbits the other 2 every 11.5 years. The system is surrounded by a disk of gas and dust, typical of a young star system. This disk is divided into rings, which contain a rather puzzling gap. Detailed modeling of the system suggests that the best explanation for its existence is a large gas planet. The results of the latest observations were published in the journal Monthly Notices of the Royal Astronomical Society. GW Orionis is well known to astronomers. In 2020, the first study of this system was published in the astrophysical journal Letters. Astronomers took a closer look at GW Orionis using the Atacama Large Millimeter Submillimeter Array (ALMA) telescope in Chile and discovered that the entire system is surrounded by a protoplanetary disk, a clumping mass from which planets form. This disk consists of 3 rings and has a gap between the innermost and middle rings. This gap is about 15 billion kilometers wide. Furthermore, the outer ring is tilted at an angle of about 38 degrees to the others. Scientists previously interpreted the observed gap as the result of the gravitational interactions of 3 stars. In the new work, astronomers used simulations to calculate the origin of the gap. They based their assumptions on observations of other dust rings elsewhere in the universe. The modeling results suggest that it was not the stars and their gravity that caused the mysterious gap, but rather a Jupiter-sized planet or several planets. We investigated a scenario in which a planet could be responsible for the gap in the disk. We compared our simulation with observations, and they match quite well, said Dr. Jeremy Smallwood of the University of Nevada, lead author of the paper. Scientists have previously discovered worlds that orbit one of the stars in a triple star system, but they have never observed an exoplanet that orbits 3 stars simultaneously. However, the new findings will need to be confirmed, and as scientists point out, this won't be easy. The transit method, which has been used to discover most known exoplanets, won't work in this case. This method measures the brightness of stars to look for small, regular dimmings that could be caused by a planet's orbit around the star. If the planet's orbital plane is properly aligned with our line of sight, such a planet will periodically pass in front of its star transiting, which causes a periodic dip in brightness. In this case, however, the orbital plane of the probable planet or planets is so aligned that the transit is impossible to detect, although this facilitated the detection of the protoplanetary disk. The best evidence for a planet or planets would come from high-resolution imaging of the system, although this is currently beyond the technological capabilities of our observatories, and the GW Orionis system is over 1,000 light-years away. Perhaps the James Webb Space Telescope, expected to launch this year, will be able to observe something. The authors of the new paper also note that 3 stars in the sky would be impossible to see from the surface of the probable planet. They point out that the 2 inner stars orbit so closely that they would appear as a single point in the sky.